So let's understand what is Git. Okay. Have you heard about Git and GitHub? So let's understand why this was created. And this was created by the same guy who invented the Linux. Okay. Why was this created? This is purely created for the use of developers and deployments. Okay. So you're a developer. Say for example, could be anything. You're a developer. The work of the developer is end of the day when the code is done, he might have 1,000 lines in the code, but it doesn't come on a day one, right? It comes on a continuous effort of every day, right? The continuous effort has to be tracked. If it is not tracked, not only his manager, that person himself will not know what they have done on a daily basis. Correct? So to track the data, what they do is they save that file as a different file every day. Correct? So you say today you started, today you have started the code, you'll say version 1, then version 2, version 3, version 4, version 5. There are high possibilities that you will get confused one day, which version are you working on? Yeah, after around 20, 30 versions, you will not even know which version you edited, in case by mistake if you edited, and what is it going on. You might miss out on the version number. Maybe the previous day you forgot to save it as a different version. You overwrite the previous version. All those things are possible. Means you're going to lose the track of what you're doing. Make sense? You will also not know what changes have been done. You have to double click, do a comparison and all those things. It's a pain. Yeah? To solve these two major problems, to understand what changes I have done and to handle the version control is what we use a software called Git and GitHub. Git is the thing which does versioning control and tracks the changes. GitHub is nothing but github.com is a remote or an internet repository. That's it. Like a Google Drive. It saves data. S3 versioning is nothing. It is just doing a versioning of the file. Does it tell you what are the changes of the file? The same file is being saved with the same name. You can go to based on the timestamp, you can go see what is it. But does it give you what changes you have done to the file? Does it tell you have you uploaded the same file? This guy doesn't. There's an algorithm written where it works on the file. It can track what changes you have done on the file. So this is a very good mechanism if you're working on some files and you're going to continuously update it. And understand, when a developer is working, it is just not one file. It is a bunch of files and in a structured manner. When a person is creating a website, they might have a tree structure of websites, right? Folders. Have you seen that? There might be multiple folders they'll create and then keep putting because when you do a click, they'll say, okay, let me take you to a different folder. You click on something, means you click, next nested click of 20 means you have 24 subfolders. And if somebody has to track the changes in these subfolders, it's going to be a messy stuff. Somebody has to do it for me. That somebody is this guy. It can track the complete changes on the folder, on the file, subfolders, subfiles, anywhere in that project. Make sense? Yeah, that is the main work of your Git, and the GitHub works as a repository. Is that okay? So in Windows, we are going to download it with this link. Okay, we're going to do the Windows stuff, and you're going to create a GitHub account. Okay, once you create a GitHub account, you should have something called like this. So this is your GitHub. This is how it looks like. So make sure you have a GitHub account enabled. And I have logged into the desktop of the GitHub account. Make sense? Yeah, this is the primary thing which you need to do. Then next is, what is version controlling? A system that keeps record of your changes. That is a true version controlling. Okay. Apart from Git, we also have its competitor, the Subversion. SVN, we call it as Subversion. Recently, Git and Github was bought over by Microsoft, right? For some 6 billion or something. They bought it. Okay. Because GitHub has repositories of most of the open source software inside that. Whatever open source are there in the market today, there is a copy on the GitHub. So it becomes a centralized place for everyone to go use it. Make sense? How is somebody making money out of it? So if you want, you can put an open source. But if you put something on the GitHub, it is by default public. If you want to make it private and you don't want to share it with everybody, you want to share it with specific people, you got to pay. Because they're going to do the versioning only for you. You understand? It's private authentication. Okay? So you pay for that. It's still worth it because it's a nice feature to have it on the internet for me, right? I might have an organization, small organization, where I don't want to have servers. GitHub is solving the problem of versioning for me. Right? Allows for collaborative, allows you to know who made changes and when. Very, very precise. Who made changes and when. Okay. So users keep entire code and history on their local machines. Yeah. Users can make changes without internet access. So that can be done with the help of this local copy of the Git. Okay. So this guy will give you a local access. Okay. This is mainly for me to manage. Okay. If I do any changes in the file, I will come to know, the Git will come to know about it and it will ask me whether you want to commit it. There are certain terminologies in Git and GitHub. Okay. It started in 2005, created by the same guy, Linus Torvald, who created the Linux operating system from Unix. And it was precisely created for Linux kernel development. There was a continuous kernel development which is happening. How do you track it? That is why it was created. Git isn't the only version control. You have something called Subversion and Perforce. Right? There are few concepts around Git which you need to understand the terminologies. The first thing is called a snapshot. When you create a file, it takes a snapshot of it. Means it takes a backup of that file. Now next, when you come and change that file, it will remember the change separately. So it has a primary copy and the changed value. You understand? Yeah. So that is how it is done. Okay. This way, Git keeps track of your code history. Essentially, records what all files your files look at a given point of time. Okay. You decide when to take a snapshot and for what files. I have an option to do that. Right. Have the ability to go back to visit any snapshots. Next thing is commit. So you do changes to the file. It doesn't mean it is a commit. Please understand. You have edited a file on your local machine. We are talking only about the local machine file management. Think we are now doing a local machine file management. Okay. You have done some changes to the file. Okay. On the Git, it will detect that, hey, you have done some changes to the file. Do you want to commit? When I say commit, I am telling Git, please record the changes. Make sense? It is saying you added this line. You deleted the third line, you added fifth and sixth and seventh line. But do you want me to record this? If you say only commit, it is going to say, okay, I will have a record. And if you want to go back, I'll help you do that. If I don't do that, and tomorrow when I come and update again, means yesterday's update is gone for me. Say for example, I have done a commit on 7th of October. 8th of October, I did some changes. I did not commit it. 9th of October, I came and edited that file and did some changes. So if you want to go to 7th, and if I have committed the 9th, yes, you can play around with these two. 8th is anyways gone. The changes of 8th is gone. I am not able to track it. You need to commit it to track the changes. Agree? Commit contains 3 parts: information about how the file changed from previous, a reference to the commit that came before it. What is a parent commit? Only then it can compare, right? What changed? Okay. Out of 10 lines, you removed 6 lines and added 3 lines. That's okay. But what was the parent commit? This is the child commit. How it was looking. And for every commit, the way it tracks is, it creates a hash code, which is looks something like this. A reference value. Okay. I think it is an hexadecimal value. Yes. It's a hexadecimal value. If you see that the value doesn't go beyond F anywhere. Correct? It's 0 to 9, A to F. It's a hexadecimal value. The only reason people go for a hexadecimal value is each digit gives you more permutation combinations. Instead of 0 to 9, you get a 0 to 16 for that 4 bits. You use it efficiently. The hexadecimal value is much more efficient than your decimal value, actually speaking. Yeah? Because each digit F is 4 bits and it uses the complete 4 bits 0000 to 1111. It's efficient. If I use 9, means it is going to use 0000 and then 1001. So it is not efficient. I still have permutation combination which I am not using. You understand? Makes sense? So we usually use for a repository, often shortened to repo, a collection of all the files and the history of those files is called a repository. So we are still now talking about local repository. Okay. It can either live in a local machine or in a remote server. The remote server is called your github.com. Okay. To play around between the local machine and the remote server, we have 2 options called pull and push. When I say pull, I am pulling the data from my remote server to the local machine. If I am saying push, it is from local machine to the remote server. When I say remote server, it is nothing but github.com. Okay. When I say clone, it is the first time copy of the complete stuff, right, from the remote machine. Apart from that, there's a very interesting concept. So whenever you create a file, it is part of the master copy. Any file which you create, we designate that as the master copy. So I told you, when you're creating a website, you might have structures of data, right? You'll have a structure of file. Each file is a master copy of its own. You agree with that? But what if I want to do some changes? Is it a wise thing to do the changes on the master copy itself? Because maybe my master copy is a stable copy now. Okay, I have put it in the GitHub remote server. And I put it in the GitHub remote server means it is public. Many people are using that master copy to build something. Okay, they are using it for the build purpose. Agree? Yeah. So will I go change the master copy whenever if I want to update the code? Because what if that code damages the master copy? The flow of it. What I'll do is I'll pull a branch out of the master copy. I'll take a copy of the master copy into my branch. Listen carefully. I will take a copy of the copy from the master into the branch, and I will tell all my developers to do the update on the branch. Do a commit on the branch. And once the owner of the master copy or the project owner sees the branch and says, okay, the code looks good, it's fine, we can now merge it to the master copy. This function, whatever just now I told you, you can do it either on your local machine or also on the remote server. Make sense? Yeah. So just to make you, so what, this is your master copy, this is a local Git, and this is your branch. Yes, I can push, I can say take a copy from master to branch. Okay, and then once I update here, I can merge it back to the master. So it is one way of doing it. Okay, and then once I update this guy, then push it to the master on the GitHub. This is one way of the flow. The other way of the flow is take out from the master, pull from this master to this master. From the GitHub, pull it to your local master, pull. Create a branch out of that file. You would have pulled the whole repository, which might have 20 files in it. Pull a branch from that file, one of the file. Take the file, create a branch out of it. Update it. Push it to the branch in the GitHub. Push it to the branch in the GitHub. Let the owner of the project be able to see the changes. Once the owner sees it, then that owner is going to merge it to the master. And then now you pull again, it will get updated to your master. You understand the cycle? This is one of the cycles many companies follow. Usually, the master is not updated by the individual developer who is doing it. Usually. There is somebody called a Scrum Master, who is the owner of the project. The Scrum Master is the person who assigns jobs to the developers. He'll say, okay, out of this is a complete project. Okay, I have some 100 development works to do. Okay, it's a big project. 100 development works to do. He'll have some 20 developers. He'll say, hey, everybody pick up 5. They call it as stories. In their development terms, they call it as stories. Pick up your stories. Okay? So they will pick up stories and they will be assigned a branch copy of that file. They'll make a local copy of it, work on it, push it back. Once you push it back, you need to inform the Scrum Master saying that my job is done. He will verify it and then he will merge it to the master if required. So that way, the master copy is always intact. So now what you're going to do is, you're just going to create an account, download GitHub on your laptop, and then we'll just create a simple file on your laptop and we'll see how we can push it to your GitHub.com. Simple thing. Yeah. Start off. Click on repositories. Click on file and say add local repository, give a path to whatever local repository you want to put it. Say I've created a path and I'm going to say folder name. Create a folder name. So B20 repo. Select the folder. Sorry, don't do an add. Create new repository. I think add will not work. It's looking for a file. Click on file, create add new repository. Okay, give a name to it. Give a path, local path where you want to keep all your files. Okay, and say git ignore all those things. License is gonna be free license, and then create it. Okay, new repository, name, path, and say create it. Is that okay? Remember the path where you have created. We need to go there. Okay, I'm going to say create repository. So now how do you make changes to that repository? Show in folder. So you actually go to that repository. You see this path, the same path. Yeah. Here I'm going to say create a file. Save file 1. Okay, I'm going to edit this file and say first line added on the local machine. I'm going to say second line and third line added on the local machine. Just save this file and close it. This is how you change. You can do the changes. You can use, instead of that, notepad and all those things. You can always say edit with notepad, always. So whenever you click on the file, notepad is a nice way of editing the files. Now if I go back to my local repository, just go back to your local repository. There is a tab called changes. It will detect the changes of the file. It will say that there is a new file which is added and there are 3 lines added in that file. Yes? Means there are hundreds of files on your laptop. Only this file has been detected. Why? Because you have said the repository folder has to be this. So anything and everything you do inside that folder, even if you create a folder inside this, and then you create another file, this file is inside the folder 1 created on local machine. You see this? It's able to detect any files within that folder, whether it is a subfolder or anywhere. It's able to detect. You get the point? Now I have 2 files created. I have to tell the Git, the local Git, please start tracing it. Do a version control. How do I do that? I'll say file 1 added. I'll say commit to master. This is your master which is on the local repository. Here, local, on your laptop. Okay, if I do a commit, it's going to make it as a master copy. It goes away from the changes. It comes in the history. Okay, so both your files are getting committed to the master. It's still here on my local machine. Okay, I can click on that file. I can see what files have been changed. No problem. Okay, now if I have to go change something, I'll say file 2, second line added after the first local commit to the local master. You see this, there is a change again detected. You understood? I'll say line 2 added on file 2. I'll say commit to the master. You understood? I'll have changes recorded. This is how I see the changes, what is being done. This is how I'm able to see what changes has been done. Initially auto detected text files, and then it says there are 2 files which were added together. Okay, and then it says this file was updated with this line. What else do you need? I mean, you're able to exactly track when and what happened to your file system. Yes, which is the best thing to do, right? Now it's time to push it to my GitHub. The only thing which you need to do here is push publish repository, give the same name so that you will know what it is. Here, the only problem is you cannot keep this as private. If you have to keep this as private, when I say publish, it will say you need to upgrade your plan. Currently, I'm on a free plan. I need to upgrade it to a premium plan. And for premium, it is monthly pay. So if you cannot keep it as private, it is going to be public. Means it is going to be accessible to everyone. Publish. You can say 4th line added on the GitHub server. Okay, I'm going to say add below. Please have a look. Below I have 2 options. Either commit directly to the master. This is the master on the server. Okay, or I can create a branch out of it. The changes which I want to save, I can say either save it directly to the master or make a branch out of it. You understand? Right? How do I know? If I go to this file, I still don't have the 4th and 5th line. Yes or no? Okay. So the only thing which I need to do is fetch origin. When I click on fetch origin, it will understand that there is some changes done on the GitHub. It will say pull, refreshing. It is trying to compare the repository from the local and the remote. Whoever has the latest data, it is going to say pull, and then, or if not, push. See, it is saying pull origin. It has some updates. If I say pull, my file now will get updated. Make sense? You follow what is happening? Yeah? Here I'm going to say 3rd line added on the remote server, saved as branch copy. Okay, I'm going to say file to B1. It's a file 2, right? I'm going to create a file to branch 1. Propose file change. Okay, I'm going to fetch it here. There are 2 pull requests, one for the master, one for the branch. But right now it all looks the same. For now it all looks the same. Okay, I'm going to show you how this is. So I have a branch copy and a master copy. If I go to my folder, I have the third line added. Now let's understand how the difference works on the local. Okay, so what I'm going to do is I'm going to update this file. Fourth line added on the local branch. Okay, added on the local branch. Okay, so I'm going to say, you see this, that is the change which is there. I'll say I don't want to do the changes on the master. I want to change it to the branch. First do a commit to the branch. I don't want to commit it to the master right now. Okay, I'm going to say fourth line added and say commit to file to branch 1. I'm going to say that. Okay, please listen carefully. Now if I do a double click on that file, I have the fourth line, but when I select the current branch as master, the file should not have the fourth line. I'm still talking about the local copy.
If you change the settings are even here also it will change.
Yeah, that is how it is managing, because this folder has been managed by whom? By the GitHub, Git. Right? So I have updated that file only in the branch. You want to know what happened? Go to the history, you will know what you did. You understood? Now I can always say, go to this, go to branch. I can always say merge into the current branch. So I can go say master repository merge into the current branch. What you want to merge? Default branch, recent branch, merge into master. There is one commit from this into available. You understand? So what you want to merge into master? This one. Right? There is one extra change on that. You understood the difference? That is how it looks. Now then when I go and merge, now both will have the same copy. Now I'm selected on the master. Now my master should have the fourth line added. You see that? But still my master on the local and my master on the remote is different. I need to push the origin. You're able to follow what is happening? Okay. So one of the flow which we did just now is local branch, then local master, remote master. This is one flow. Okay. I could also say remote branch, remote master, and then local master. This is another flow. The next flow is very interesting. Local branch, remote branch, remote master, local master. You see the flow, how it is happening. These are the different flows which you can gain. Where you want to update what? So there is a structure flow which will be done once and people follow that pattern. They will not keep changing for the project. For a single project, they'll say, okay, this is the flow you need to maintain. They'll never keep changing the flow because it's going to be confusing so much. And at the end of the day, you will not know which copy is where. Because you have 4 copies now. Remote branch, remote master, local branch, local master. 4 copies.